In this video, we will talk about counting principles. This is our third topic of our probability unit. Counting principles gives us ways to determine numbers of groups of items. In our unit on basic probability, we talked about different ways that we could find groups, such as tree diagrams or charts. We use charts especially when rolling two dice and finding a sum, and we use tree diagrams usually for flipping a coin, heads or tails. In this example, in your closet you have 3 different shirts, 4 different pairs of pants, and 2 different pairs of shoes. How many ways can you choose your outfit for the day? So I have a little clip art diagram here for you. You have 3 different shirts that you could pick, and then for each one of those 3 shirts you have 4 different pants options, and then for each one of those 4 pants options you have 2 shoes options. So for each shirt 1 to 3, you have 8 different possible outfits you could make, giving you 24 different possible outfits total. Now that seems okay. It's not ridiculously large, but let's say you had 20 shirts and 8 pairs of pants and 12 pairs of shoes. It would be really annoying to have to make a tree diagram for that. So in comes what's known as the counting principle, fundamental counting principle. The fundamental counting principle says if that we have n items, so in my shirt and shoes example, my n was 3 because I had shirt, pants, and shoes. And I have m sub 1 ways to choose the first item, so that would be 3 for shirt, and m sub 2 ways to choose the second item, and so on and so forth. Then there are m sub 1 times m sub 2 times m sub n ways to choose n items. So I like to use a kind of fill in the blank method here. It helps me visualize the problem. And in the blank, I write the number of different possibilities for each item. So I have 3 different types of shirts, 4 different pairs of pants, and 2 different pairs of shoes. The fundamental counting principle says that I can just multiply those numbers together and it gives me the total number of possible outcomes. So in this case it would be 24 outfits. For lunch, you have a choice of 3 entrees, 3 side dishes, and 4 drinks. How many different meal choices are there? So again, here we can use the fundamental counting principle. I have E for entree, SD for side dish, and D for drink. I have 3 different entrees, 3 different side dishes, and 4 different drinks. So using the fundamental counting principle, I can just multiply those together, and that gives me a total of 36 different lunch combinations. Now that was a lot easier than having to draw a tree diagram for each one. Saved myself a lot of time. Every telephone number starts with an area code. So you might have an area code of 732. I have an area code of 201. You might have an area code of 908. In New Jersey, though, area codes only start with a 2, 5, 6, 7, or 8. If the 4th number of your phone number cannot be a 0 or a 1, so you couldn't have like 732, 0, 6, 4, blah, blah, blah. How many possible 10-digit numbers are there in our state? So 732, this would be my blanks for my area code. So I know my first digit, I can only have a 2, 5, 6, 7, 8, or 9, so that's 6 different possibilities. For my other digits, I could have 0 through 9, it doesn't matter. So my first blank, I have 10 different possibilities, and for the second blank, I also have 10 different possibilities. Now I know the 4th number can't be a 0 or a 1, so that only leaves me with choices 2 through 9, which is 8 different digits. But for the rest, it doesn't matter. So for each of these, I have 10 different possibilities of digits for my phone number. And to get the total number of combinations, I can just multiply those together. So I'm going to multiply the 6 and the 8. That gives me 48. And then remember, multiplying by 10, you just add zeros. I'm multiplying by 8 tens. What, did I miss one? Yep. I'm multiplying by 8 tens, so I need 8 zeros. So that gives me a possible combinations of phone numbers of 4,800,000,000. It's kind of a lot. A permutation is an ordering of objects where the order of those objects is important, meaning that the order of the objects, if they're in a different order, gives you a distinct new combination. A good example of a permutation says, how many ways can you arrange the letters in the word love? Arrange is a key word. Usually when you see arrange, that tells you that you're dealing with a permutation. So what it means is that if I rearrange the letters and make it E-V-O-L, that's a different combination than if I had V-E-L-O. They're still using the same 4 letters, but we're just putting them in a different order. So if you think about this using our fundamental counting principle, for the first letter, I can use one of 4 letters. It doesn't matter which one I choose, right? So let's say I pick an E, but I had 4 different possibilities. Now, after I've picked the first letter, I only have 3 letters left. So say I pick L. I had 3 options left. Now that I have picked the first 2, I only have 2 left for the second and 1 left for the last letter. So using the fundamental counting principle, I can multiply those together, and that gives me a total of 24 different combinations of the letters in the word love. This is what's known as factorial. You'll see this exclamation point. That's an operator. It means factorial. Like a plus sign is an operator that tells you to use addition, and a minus sign is an operator that tells you to use subtraction. The exclamation point in math is an operator that tells you to do a factorial. And what a factorial is the product of the natural numbers less than or equal to that number. So in my love example, this is really 4 factorial because it's 4 times 3 times 2 times 1. It's 4 times all of the numbers less than 4 until I get to 1. This example is 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. That is what factorial means. Your calculator will do this for you very conveniently if you have a graphing calculator. Let's say I want to do 10 factorial because I don't want to have to multiply all those numbers together. If you type in 10 and then go to the math button, here it says probability, which is where we'll be working with today mostly. You'll see number 4 is a factorial. So if you get 10 factorial, that very quickly gives you 3,628,800, a lot faster than you could in your iPhone type 10 times 9 times 8 times 7, which is what you'd have to do if you didn't have a graphing calculator. Sometimes, though, you only want to order a certain number of items in the group. In our love example, we had 4 things and we wanted to arrange all 4 of them. But if you think about something like running a race, if there are 7 different people running a race, really you only usually get a prize if you come in first, second, or third. It doesn't really matter if you come in 5th or 7th. All that matters is that you didn't come in first, second, or third. So for the race example, if I use my fill in the blank method, how many people could possibly come in first? Well, 7, because there's 7 people who ran the race. After my first person has come in, now there are 6 people left that come in second. And after first and second have come in, now there are 5 different people left who could come in third. And to calculate this, I can use the fundamental counting principle and multiply those together. And that gives me 210 different ways that people could come in the race. We could also do this using factorial, right? 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1, except that takes into account the order of the people that came in 4th through 7th. Now again, we don't really care what order they came in, so to kind of compensate for that, what you would do would be divide this by 4 factorial. This denominator here would eliminate the combinations of the people that came in 4th through 7th. If you multiply that out, I'll show you what it looks like. This would be 7 factorial. This would be 4 factorial. And then you'll notice the numbers 4 through 1 appear in both the numerator and the denominator, and those cancel out. So you're just left with what you got when we did our fill in the blank example. Here is a formula that can be used to find permutations. you'll see here, this notation, the capital P stands for permutation. Again, the N is your total number of objects, and the R is how many you're taking at a time. So a permutation of N items chosen R at a time is this equation, P factorial over N minus R factorial. You'll see here on the left is the example of the race. There are 7 people total, that's my N, and I'm taking 3 of them at a time because it's only first, second, and third place. If I were to use the permutations formula, that would give me 7 factorial over 7 minus 3 factorial, which is exactly what I did up at the top here when I wrote out the long way of doing it to kind of show you how things cancel. Now again, your calculator can do this for you if you have a graphing calculator. If you look at the probability menu, number 2, NPR, that is a permutation. So the first thing you want to do is type in your N, which would be 7. And then you scroll over to probability, hit 2, and then put in your R value, which in this case would be 3, and that again gives you 210 different possible combinations for the race. How many different ways can a club select a president, vice president, treasurer, and secretary from a group of 11? So I have 11 people. I'm taking 4 of them at a time because there are 4 different positions that people can be in. So that would be 11, choose 4. So you can either use our formula, and calculate it this way. So this would be 11 times 10, 9, 8, 7, and then from 7 on down to 1. I'm not going to write them out because you'll see at the bottom I have 7 on down to 1 here. All of these are going to cancel. And you're just left with 11 times 10 times 9 times 8, which gives me 7,920 different possible combinations for the club. So you could do it like that, or again, you could use the calculator. I'd have 11. Maybe. 11. I'm choosing 4. 7,920. Sometimes we see permutations where objects in the group are repeated, like in the example of finding the ways to arrange the letters in the word class. You'll see that the S here is repeated twice. So in this case, the first S times, or the first S, not times, but if I had LASSC, that would be the same as if I just switch those 2 S's because the S's are the same. So to compensate for the repeated item, we have this formula up top, N factorial over Q factorial, where N is the total and Q is the number of repetitions. So in the word class, my N is 5. But Q here is 2 because I have one object that's repeated 2 times. So that gives me 2. So this would be 5 factorial over 2 factorial, which you could work out either in your calculator or longhand with multiplication. That gives me 60. The example Hannah is a little bit different because the H and the A and the N are all repeated twice. So instead of just having a 2 factorial on the bottom, you have to have 2 factorial 3 times. 1 for the H, 1 for the A, 1 for the N, and that would give me 90. A combination is sort of like a permutation, but the difference is that the order is not important. Permutation, the order was important. Combination, it's not. An example of this would be choosing students for a group. If I am making a group of 5 students and I have a class of 20, it doesn't matter the order that I call those students' names. If I first call Joe, then Matt, then John, then Kate, then Emma, that would be the same group as if I called Kate, then John, then Joe, then Matt, then Emma. They're the same exact group of people. It's just that the order that I called their names in is different. So that is the difference between a combination and a permutation. If this was a permutation, let's say I was calling for first through fifth place, then this would be distinctly different than this. But because the order doesn't matter, that makes it a combination. And combinations have their own formula. You'll see here, instead of a P, now I have an N. And my formula is almost exactly the same, except in my denominator, I'm multiplying by this R factorial out here. So if I have the example of 7 items taken 3 at a time and it's a combination, this is how I would plug it in. Again, you can use your calculator. So if I want to calculate a combination of 8 things chosen 3 at a time, again, I'm going to start with the 8. And then when I go to the probability menu, I'm going to pick number 3 because that's the combination instead of number 2. Whoops. Try that again. It gives me 56. So 56 different combinations. In general, there are less combinations of items than permutations. Since the order is important, or since the order is not important, it kind of narrows down your unique number of groups. You were adopting 3 kittens from a litter of 11. I don't know why you'd want 3 kittens, but maybe you do. How many different groups of kittens could you possibly adopt? Now, you'll see the word group here. Groups is a keyword that tells us combination. Not always, but most of the time when you are making groups of things, the order of those things doesn't matter. So if I have a combination of 11 things taken 3 at a time, you can either use your combinations formula, 11 factorial over 3 factorial times 11 minus 3 factorial, which gives you 11 factorial over 3 factorial times 8 factorial. Or you can use your calculator. 11. Choose 3. 165 different possible groups of kittens. It's a lot of groups of kittens. Three students out of my total of 50 will be randomly selected to receive a free pass from the quarterly. How many different groups of students could be selected? So if we think about this, if I just took all 50 of my students' names and put them in a hat, it wouldn't matter if your name was called first or second or third, as long as I called your name to get that free pass from the quarterly. So this tells me that it's a combination, also the word groups, because the order that I call the names in doesn't matter. You don't get an extra pass if I call your name first. Just the first 3 people called get a free pass. So here this would be a combination of 50 things taken 3 at a time. So I can do this in my calculator. Choose 3. 19,600. That is a lot of different groups of people I could call to get a free pass from their quarterly. So good luck with that. Lastly, here are just some examples of different combinations and permutations and how we can tell the difference between them. So in blue here, how many ways can 7 students come in first, second, and third place in a math contest? So in this case, coming in first place is different than coming in third place. So that tells me that this is a permutation. Here I have how many shirt and pants combinations. So it has the word combinations right in it. That tells me it's a combination. So if you have like a red shirt and black pants, that's the same group as having black pants and a red shirt. You're still putting on the same clothes. The order of them just doesn't matter. How many different orders, so the word orders here kind of tells us that it's a permutation. Can the fireworks colors appear? So orange, then green, then purple, then blue would be different than green, then blue, then orange, then purple. So that's a permutation. How many ways can I arrange the letters? Again, this word arrange is important. It tells me that this again is a permutation. So that goes over here. And then how many ways can a group, keyword group, so that tells me combination of students be formed. So I hope you found this video helpful in determining the difference between combinations and permutations, and then how to use your calculator or the formulas to come up with numbers of groups. Good luck.